Welcome to homework.
So we know the focal length of the two lenses here, f1 and f2, as well as the distance from the object, p1, to the first focal length, f1. And we also know the distance between the two lenses, which I call d, and that's 32 centimeters. So for part A, it wants us to find the distance to the image produced by the second lens, I2. So to do that, we first need to find the distance that's produced by the image of the first lens, I1, and then use that as the object of the second lens. So to do that, we use the equation 1 over f1 is equal to 1 over p1 plus 1 over I1. So we can rearrange this to solve for I sub 1. And we find that I sub 1 is equal to 1 over f1 minus 1 over p1. And then I was in the denominator, so therefore we have to raise both sides to -1 to get it to the numerator. So 1 over f1 minus 1 over p1 to the -1 is what the right side of the equation equals. Plug in those values, and we find that this is equal to 24 centimeters. So therefore, p2 is going to be equal to d, the distance between the two, minus I1. So that I1 becomes the object for the second lens, and we find that it's a distance away of 8 centimeters from that second lens. So now we solve for I2, and since it's the exact same equation as I1, we can just replace the values in I1 with things with a subscript of 2. So this is going to be 1 over f2 minus 1 over p2 there we go, all raised to the -1. So if we find a value for I2 of 24 centimeters. And we can go ahead and box that in as the solution for part A. Part B wants to know the magnification of the two lenses. So to find this magnification, we just simply multiply the magnification of lens 1, which is minus I1 over P1, by the magnification of lens 2, which is minus I2 over P2. So that's our total magnification. And we carry out this operation, and we find the magnification is equal to 6. For part C, it wants to know if the image that is produced by the second lens is real or inverted. To do that, we can just look at the value for I sub 2, and we can say that since the image produced by lens 2 is positive, the image is real. We can box that in as our solution for C. Part D wants to know if the image that is produced is inverted or non-inverted, and we can look at the value of our magnification to do that. And since M is positive, the image is non-inverted. We can box that in as our solution for D. And then lastly, part E wants to know if the image that is produced is on the same side or the opposite side of the two lenses as the object that produced this image. And since the image is real, it is on the opposite side. We can box that in as our solution for E in the final part of our question.